Hi, everybody. Welcome back from a long weekend. We'll continue on today in our next topic that I'll lead you through for today and tomorrow of physical and chemical properties. Tomorrow, I'll even do a little lab demonstration where we'll answer this question: how can you identify different substances if they look exactly alike? And we'll take a look at four clear liquids, and we'll try and discern what they are based on their physical and chemical properties. But really, when we talk about physical and chemical properties, we are looking for a variety of means to describe matter. So things like oxidation or rusting, flammability, the state of matter, whether it's in a solid or liquid or gas state, or perhaps even if it is a decomposing fruit. Today, your work is going to be to do a reading. And you can either do that reading with me, we'll read along together and fill out our notes together, or you can set up the table on your own, as you'll see in the next slide, and you can do the reading on your own. But in any event, I need you to set up this table on page C9 of your notebook. And I'd like you to make a point in your notes column to define these three terms: properties, physical property, and chemical property. This is not the first time that you've seen this term property. We've been talking about properties since the first week of school, if you recall, in our Properties of Water lab. So you'll have at least those three notes in the notes column. And then as far as taking your notes in the physical property and chemical properties columns, I want you to look for these terms as you go through the reading. There are 11 of them, and you are going to categorize each one, each phenomenon, as either a physical or chemical property, and you'll read about that. So in your table, you'll have these 11 terms categorized into either physical or a chemical property, as well as those three notes that I asked for. And then at the bottom of the page, I'm actually going to have you set up an additional little mini table. So when you get to page 3 of your article, you're going to see this table. And I am going to have you fill it out, but I don't need you to copy down the description. You'll just read through the description of what is occurring to the wood, the iron nail, potassium, and to the fruit, and then you will draw this small version of the table. So beneath the other table, your completed page on C9 will actually have the larger table that you just drew at the top, and then this smaller one at the bottom with the four substances. And then this time going to have you guess which chemical property might be occurring there. And again, you'll find that information in the reading. Okay, we'll go ahead and continue on to the reading. The first page looks a little something like this. This PDF is attached with our assignment for today, so you'll either follow along with me or you will continue on your own. Okay, here we go. How can you describe a piece of paper? You can talk about its color and size. What other properties of paper can you identify? Imagine that you took a full sheet of paper and you folded it into a paper airplane. Would you still have paper? Yes. Being flexible or foldable is a property of paper. Will paper burn if it's near a flame? Yes. Being flammable is another property of paper. You could measure other properties of the paper, such as its mass, volume, and density. Properties help distinguish one substance from another. Next, you do see that your first definition is right here: properties. Physical and chemical characteristics of matter used to describe or identify a substance. So go ahead and add that into your notes column. Pause me at any time, of course. I'll continue on. Not all properties can be seen when you first observe or measure a substance. Physical properties can be seen without chemically changing the matter, while chemical properties are observed during a chemical reaction. We'll spend all of next week talking about chemical reactions. But for right now, let's differentiate between physical properties, or those where we don't change anything about the matter, but a chemical property is observed when something is changed in the chemical makeup. Continuing on. Physical properties are characteristics that can be observed or measured without changing the substance, such as the state of matter, solid, liquid, or gas, the color, the melting point, the boiling point, the odor, the density, and the conductivity. Notice that list is what you need to include in your table. Some of the terms that you need to include on your table were just read, so go ahead and go back. And here come the chemical properties. So these are characteristics that can only be observed or measured when atoms of matter rearrange during a chemical change, such as flammability, such as during burning, corrosion and rusting, or oxidation, that is reactivity with oxygen in the air, and reactivity with water. Some metals explode when they come in contact with water. This next section is a little bit of bonus information. So even though you won't be tested on the words intensive and extensive properties, it's a little bit of additional information that will make you that much more knowledgeable. Congratulations. Some physical properties depend on the size of a substance. An intensive property is a bulk property. It does not depend on the amount of matter. Intensive properties include the shape, the state of matter, the color, the temperature, the density. Does it sink or float, or grams per cubic centimeter? The hardness, its resistance to breaking, things like the luster or shine of matter, the texture, the malleability, its ability to flatten, its ductility, its ability to be drawn into a wire, the flexibility, its ability to bend, attraction or repulsion to magnets, melting point, boiling point, odor, heat, conductivity, electrical conductivity, solubility, that's the ability to dissolve in water, and viscosity, its resistance to flow. For example, when a diamond is cut, the pieces maintain their intrinsic property of hardness. A piece of paper remains white even if it's folded. Water will freeze at 0 degrees Celsius regardless of the amount of water present. So intensive properties can be observed and measured to determine the identity of a substance regardless of the amount or the quantity of that substance that's present. In contrast, an extensive property is proportional to the amount of the material. So examples of extensive properties include the mass, the length, and the volume of matter. A ream of paper, so that's like the square package, rectangular package that printer paper would come in. A ream of paper has more mass and volume than a sheet of paper. A foot-long hot dog has more length than a regular hot dog. So that's just a little differentiation between those properties. Good news. The next section of the reading is totally review to you. We did a whole unit on measuring physical properties accurately at the beginning of the school year. Things like finding mass, finding length, and volume is what was beneath finding length in the PDF. So I'm going to have us just leapfrog and jump right over that. By all means, if you would like a little review of how to find mass on a triple beam balance, or how to use a metric ruler, or using a graduated cylinder, by all means, please do read through that. Otherwise, we'll continue on. So our very last page of the article that I'm asking you to read and to become familiar with is this second table that you'll fill out. So the instructions say, consider the following objects and describe some of their chemical properties after observing a chemical reaction, which again, we'll spend more time talking about what exactly is going on in a chemical reaction. But essentially, we're talking about the atoms involved in a molecule, rearranging and changing configuration such that a new substance is formed. So in this first entry here, we see the substance is wood. So that's going to be this first image. Wood, the description is wood catches on fire, displaying the production of light and heat. What chemical property might be exhibited there? Well, that would be flammability. So wood has the chemical property, the potential to be flammable. It has a chemical property of flammability. I'd like you to try the next 3 on your own. I know you can do it. We will do a review tomorrow of everything that was entered in the table. So we'll make sure that we all have that information and that it is complete. Okay, great job. Thank you for your attention today, and I will see you tomorrow for our lab.